Hi, this is Craig Stocks here at Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today I'm going to go over this image that was captured in RGB and luminosity. And the question came from one of the viewers asking for specific help with combining RGB and luminosity in Photoshop. So this is what we're going to go through today. So this is kind of the end result or the goal, and this data was captured by Jeff Kisslinger. I guess, did I say that right? Kinslinger, I believe. He captured this with a 11-inch Edge HD, a Celestron with a Hyperstar attachment. So it's a much wider focal length, much wider field of view than you would normally get with the 11-inch Edge HD. And kind of an interesting combination that it's rather than capturing LRGB with a monochrome camera, he captured the L data with a monochrome camera, and he captured the RGB with a similar RGB color camera. Both were the ASI 2600. MM Pro for the monochrome and MC Pro for the dual, for the color. So let's go back in time and see how we got to Photoshop. So we'll hop back over to PixInsight. This is the files that I saved as 16-bit TIFFs to open in Photoshop. And you can see that there's the luminance that was captured with the monochrome camera. And this has been processed into a starless image. And the basic processes I went through were gradient correction with Graxpert, blur exterminator. I applied a slightly modified screen transfer stretch, and then ran it through noise exterminator and star exterminator and saved it as a 16-bit TIFF. So that gives us the mono starless image. And then I did essentially the same thing with the color image. The one additional step was running spectrophotometric color calibration. Now, since these came from two different cameras, creating a matched set, there's a couple different ways you could do that. And I think the way Jeff did it, it looks like he ran the monochrome data through WBPP as one set, and then ran the color data through WPPP also as the color set, and then did a star registration to align one to the other, and then a dynamic crop to crop them both the same. So, what he provided me were the matching master lights with no other processing other than ensuring that they were registered, and I think he did a dynamic crop to clean up the edges. Probably wouldn't be feasible to try to run them through WBPP simultaneously, because you would have to configure things so that the cameras and the darks and the biases and the flats all matched up correctly. So it's probably easier to run them separately. The other option would be run them separately, but in the second run manually select the same reference frame that was used in the first run. You can find that information in the log file, or just do a star registration when you're done the way Jeff did. Either one will work just fine. But this gave me the three files of the monochrome luminosity, the color information, and then the stars that were extracted from the color information. Those three are saved as 16-bit TIFFs. So with that, we'll go to Photoshop, and let's just start from the beginning. I'll go to File, Scripts, Load Files into Stack, and I want to browse for the three. There's the three files that we're going to use, and I'm sorry, this was over on the other monitor. So this is the three files that I've selected for load layers. I got to that by the Browse button, and now click OK. And Photoshop will load those three files in the Layers palette or in the Layers stack. And you never seem to know for sure what order it's going to load them in. So we've got the luminosity, we've got the RGB color, and then we have the stars. So now I've got them ordered with the stars on top, then the RGB, and then the luminosity. The basic process that makes this work is blending modes. So without doing anything else, if I just put the stars in screen blending mode, and whenever I use Star Exterminator, I always check the box to unscreen the stars. So since the stars were unscreened in PixInsight, if I choose screen for the blending mode, and there's a lot of different blending modes, that puts the stars back in mathematically the same way they were taken out through a screen or unscreen process. So now we're looking at the stars and the color layer. From the color layer, we really only want color. We don't want the detail. We want detail to come from the luminosity. So I'll put the color layer in color blending mode. And now we have the stars in screen blending mode, we have the color in color blending mode, and we have the luminosity just as the base layer. So it's really, the construction is really that simple, just using blending modes to select how each one of those layers is blended together. Now I actually like to do things a little bit more organized, so I'm going to go back in time to where we have the layers ordered. And I like to put everything in a layer group. And the reason I do that is basically what happens in the group stays in the group. So I'll put the stars in a group by tapping Control G. That would be a Command G on the Mac. And now I'll label this group stars, and I'll put the group in screen blending mode. So the stars layer is in its normal blending mode, but the layer group as a whole is in screen blending mode. And what that lets me do is, if I add, for instance, a levels adjustment within that group, I can use the slider in the levels adjustment to brighten or darken the stars independently of the background. So, that's why I say what happens in the group stays in the group. We can also now turn that group off and do the same thing with the RGB layer. Control G, we'll put it into a group. We'll label it RGB. And we'll put this layer group now in color blending mode. And lastly, we'll turn that off and focus our attention on the luminance layer. Control G, I'll label it Lum. And here, I'm pretty sure I want to adjust the brightness of this because it's pretty bright. The dust is all pretty bright from the way it was stretched in PixInsight. So I'm going to add a levels adjustment layer, and I'm going to darken the midtones and bring that down a little bit. And when I darken those, that's also darkening the blacks to the point where some of this data might be clipping. So I'm going to brighten the blacks a little bit to keep these dark areas from getting too dark. And I'm going to do that. The sliders at the top make, the dark slider makes the blacks darker, or the darks darker. This bottom slider makes the darks lighter. And you kind of get a hint of that by this gray scale that's above these two sliders. So you can think of the position on the gray scale as being the point of blackest black. So if I slide this to the right, I'm making the darkest dark or the blackest black a little bit lighter. And you can see, hopefully you can see in the video how that's retaining the detail in some of those dark areas. So, maybe something like that looks good as a starting point. And then when we add color, it starts to look quite a bit different. And sometimes when you add color, you want to go back to the luminosity and change the brightness. Notice that since this RGB layer is in color blending mode means it can't have an effect on brightness or luminosity. So for instance, if I add a levels adjustment layer within that RGB group and try to change the brightness, it doesn't really have an effect because all it's affecting is the brightness of the color. It's not really affecting the brightness of the image. So if you want to change the brightness of the image, you really need to use a levels or curves or something in the luminosity group and just adjust it to taste and then turn the stars on, and you've got a pretty decent finished image. If we want to add some sharpening, generally speaking, sharpening the color layer doesn't do much for you because it's really just color data, but sharpening the luminosity will have an effect. So I'm going to do a couple steps here. First, I'm going to convert this into a smart object so that I can use non-destructive smart filters. And now I'm going to go to Filter, Sharpen, Smart Sharpen, and I'll apply a modest or medium amount of sharpening here. These are fairly high resolution images, so they can take a fair amount of sharpening. And I can turn this filter on and off to see the before and after. Not a huge difference, but some difference. Now I'm going to convert this into a smart object again. And the reason I'm going to do that is I'm going to add some local contrast, and I will probably want to mask out the effect of this in these brighter areas. So I'm going to use the Highpass filter, and to do this you have to do it in a couple steps. It's under Other, Highpass, and the setting doesn't really matter at this point. I'll just select OK, because I first have to change the blending mode of the smart filter. So I need to change the blending mode of this Highpass filter, and I can get to that through the little adjustment icon over on the right by double-clicking on that. That brings up the blending options for this smart filter, and now I can change it to soft light. You can use either overlay or soft light. I prefer soft light because it's a little softer and less gentle than overlay. And you can immediately see the effect that that had. It creates local contrast by brightening the brights and darkening the darks that are next to it. Now, since this is a smart filter, I can double click on Highpass, and I can experiment with the different settings, and I may find that a very large radius or a smaller radius, that I think I like a large radius with this data, and there would be nothing wrong with doing it more than once. Sometimes it becomes too strong in bright areas like this. If I turn the smart filter off, you can see that it's really washing out some of the detail here. So I'm going to click on the smart filter mask, and I'm going to grab my brush tool, and with black as my foreground color, and I'll just go ahead and start at 100% opacity and just paint over this very bright area on the mask with black, and that'll hide the effect of this filter in that area. So we still have the sharpening that we applied initially, but we're not applying the Highpass filter, which is what was causing it to become too bright. There may be other areas that are also driven a little bit too bright, so we'll mask the Highpass filter there, maybe there. This is probably okay. I may just leave that the way it is. So at this point, that's pretty close to a finished image. I would usually add some global adjustments. So above the RGB layer and below the stars, I would typically add a levels, a color balance, hue saturation, and then the last thing I add is a solid color. And I want RGB values of 19, 19, 19. And I can get that by typing 13, 13, 13 into the hexadecimal field. And then we'll put this in lighten blending mode. And I don't know if this is going to have an effect anywhere. Let's turn it on and off. Not really having a visible effect right now. Maybe a little bit of an effect in here. what it's doing is creating a floor or a minimum darkness level of 13, 13, 13, or 19, 19, 19 RGB. Because when you get darker than that, frequently all you have is noise. So anything that's darker than that gets smoothed out. And then I can play with this, the black level in this global levels, and darken it down a little bit, basically just creating a little bit more contrast in the image. And we may want to add a little bit more color saturation, which I can do with the saturation slider. There's a fair amount of red over here, which I'm guessing that is probably hydrogen, ionized hydrogen cloud, as opposed to light pollution or something like that. If it's light pollution, we could take that red saturation out, and we could do that with a hue saturation adjustment level. So I'm going to, if you do want to take that red out, what I would do is add another hue saturation adjustment layer, and then instead of targeting the master, which is all colors, I would target just the reds and remove just the red saturation. And so that has taken the red saturation, the red color out over here without affecting everything else. Looks like there's a little bit of a cyan color cast overall in the central area. So I would probably go down to the color balance and maybe add just a touch of red and neutralize that color a little bit. If you do like if that red does belong there, then you would not add this second hue saturation adjustment layer. And it would probably be worthwhile, if you have a hydrogen alpha filter and a filter drawer on your setup, to go back and capture some hydrogen alpha of this same region with your monochrome camera, and then you could add that in, and that would add even another dimension of color and depth to the image. So that's kind of it in a nutshell. It's really quite easy to blend luminosity and RGB. The main trick is in the blending mode that's chosen. The bottom of the group is the luminosity, and that's just in simple normal blending mode, or the default for a layer group is pass-through. The RGB adds color, and then we've added some global adjustments to tweak it globally and fine-tune the image as a photo. And then lastly, we can turn the stars on, and that's a finished image. I hope you found this useful. If you have any questions, drop those in the comments down below. Thanks again to Jeff for providing the data. This made for an interesting and unusual combination of combining luminance and RGB from two different cameras. And as always, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.